Hello and welcome back to Problem Solving with SQL. Today is actually the first time I have a request coming in for how to solve a problem. I thought it was really interesting. We're going to be looking at how to solve we're going to call it a weighted median. So this is kind of an interesting problem because I've actually been asked it before in an interview, and I only had like 2 minutes left at that point, so I never had a chance to actually think about how I'd respond. I'd set up the data this way to save space, but I never actually got to answer it. So let me tell you what I mean. So let's say we have this table. So we got this table. It basically stands for like an age experiment, whatever it might be. We've got this group of people with ages, and so we have their age and the total amount of people in that age group. So we have 10 people that are 0, so under 1. We have 12 people that are 1 year old. We have 3 that are 2, 21 that are 3. Okay, so we have this kind of already grouped together, aggregated set of data, right? And we want to find the median here. And if you don't remember what a median is, essentially you're kind of cutting off from both sides until you find the very middle number in between a group of numbers. So if we were to take, something like 1, 2, 3, 4, 5, we would cut off, the 4 and 5, we'd cut off the 1 and 2, and we'd be left with 3, and 3 is the median. Except for here, our data is all condensed, right? So we know that there are 10 ones. We know that, this looks like 1, 1, 1, 1, until 10. And then we know that's 0, 12 ones, 10 zeros. So we know that exists, but we don't, it's already condensed. So obviously one way you could do this is try to somehow hack together a way to parse all these numbers out, right? So you just manually now go through and unravel these numbers, essentially, de-aggregate them. But that actually, 1, is very space ineffective, and 2, is probably ineffective from a style of coding. So I thought about this for a long time, and I was like, okay, how do you figure out an elegant solution? And I think I came up with a pretty elegant solution that looks, it's clean. I'm pulling it up now. Hold on. Okay. And if you recall, last time we used this rolling sum, and I was actually really excited because I was like, oh my gosh, this is a place we can use rolling sum. So let's look at this inner query first, because that's kind of the portion that does the basic magic. So what we're going to do in this inner query is we're going to use this rolling sum here. So if you don't remember, this sum with the total over statement is a rolling sum. So what it's basically doing is it's aggregating the total value, this 10, 12, 3, in a rolling fashion. So if we were to see this in a table, let's look at this in a table really fast just to see what it looks like. So what it looks like, right, is for age 0, we have 10 people. For age 1, we have 22 people, right? Because this is actually 10 plus 12. So the 10 plus 12 right here. And then for age 2, sorry, I'm keep skipping the 0. So age 2, we have 25 people because that's 10 plus 12 plus 3. So that's that rolling function. And then 61 is just the total. And we just did that sum here just so we didn't have to group by anything. This whole section here, so we don't have to group by anything. We can just have this sum saved up. Okay, so now we have this information, right? So we know what the rolling sum looks like. We kind of have an idea basically of how many exist in each section. And you might be sitting there wondering, like, okay, why is this important? Why is it important that we know kind of how many numbers exist at each of these sections? At 1, we know there's 22 people. Well, remember that the way this kind of works is we pick kind of the middle number, right? And there are some more specifics that get into there, like, do you do +1, do you do -1, blah, blah, when you're dividing, and you've got an even split. But that's besides the point. You're picking the middle number. That's kind of the gist of it. So what this is doing is helping you figure out, well, if I know that 61 is the total and I want to pick the middle, now you kind of know where you're going, because okay, it's got to be somewhere, between 25 and 46, right? And so you're guessing, well, oh, it's got to be, well, it's not 25, right? Like, this is basically at 2, that's 25. So it's got to be in 3. The medium is in 3. And so you already know that information. And so basically that's where the outer portion of this query kind of sits. And that's where this where statement comes in. So this where clause at the very end, you'll see says where basically the running sum is greater than or equal to the total divided by 2. Again, that kind of middle number. And you could, again, be more specific with this. People who are more exact about median and what it means, you can be more specific about this. But this will basically tell you, okay, well, we want to find wherever the running sum is greater than or equal to the total, and then we'll order it by age because we already ordered everything. And that will give us the right one when we say top one. So this top one will just select the top one. And so when we run this, we'll see, we get 3 because 3 is the median. And that's really it. This one was a pretty quick video. And it really is, I think this is kind of an elegant solution. You can end the video here now. I'm going to kind of talk about some thoughts about this in general for the next little bit. But yeah, that's the video. If you have any specific questions or, again, have problems you want solved, feel free to ask. There's a lot of problems we can solve, and thank you. Okay, so